Okay, Chapter 2, homework. We're going to start with practice A, so we'll do A1. Whenever we read a problem in physics, we're not going to read the whole problem initially. We're going to chunk it. So chunk it means as I'm reading the problem, I'm going to extract out the information. I'm going to write it down. So for every problem, I'm going to write my given, and I'm going to write what I want to find. So for problem number 1, it says Heather and Matthew walk an average velocity of 0.98 meters per second eastward. So before I go on, in my given, and if you don't remember from math class, a little line above something means average. So they walk 0.98 meters per second east. I'm just putting capital E for east. It takes them 34 minutes, so now they're going to give me the time, to walk to the store. What is their displacement? So I want to find X. Now before I go on, the first step is to write my basic equation, rearrange the equation, substitute and solve. But what I'm going to notice is that this is in meters per second and this is in minutes. So I can see already that seconds and minutes aren't the same. So before I go on, I'm going to convert this minutes to seconds. If I don't do it while I'm canceling, my units wouldn't work out. So if I have 34 minutes, remember, minutes is like it's in the numerator, and I want to convert that to seconds. If minutes is in the numerator, I put it in the denominator, and I want to go from minutes to seconds, and there's 60 seconds in a minute. So now my minutes cancel out, and I end up with seconds. I take my calculator, and I say 34 times 60 equals. So that's my seconds. So for every problem now, I'm going to write my basic equation. So my basic equation is that velocity is really equal to the change in displacement over the change in time. V is equal to delta x over delta t. In middle school, you learned speed is equal to distance over time. So now we have velocity as displacement over time. Now I'm going to say, what do I have? Well, this is what I'm given. See how I put little checks next to it? So this is what I want to find. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So when I do that, x is equal to v times t. Because see, I just multiplied the t times both. Again, I don't write the deltas usually because I know this is a time interval. So now I'm going to substitute in my values 0.98 meters per second times the time in seconds. Now there's a couple of things going on right here. First of all, when I carry my units through here, it's really easy. See how this is multiplication. So you see how this second in the denominator cancels with the second in the numerator, and I'm going to end up with meters. Is meters the correct unit for displacement? It is. So that's a full. Now what if I didn't convert this to seconds and I left it in minutes? Would the minutes cancel with the seconds? So then I would say, oh, I need to convert the minutes to seconds because otherwise they won't cancel. So that's why it's always important to carry your units through and cancel them, because it's going to check if you have to do a conversion, and it's also going to check your algebra. Okay? Now, when I multiply this on my calculator, so 2040 times 0.98, I end up getting this big number. I get that delta x is equal to 1999.2 meters. But that's kind of a big number, and this has two significant figures, and this has two, so my final answer would be two significant figures, which would be 2.0 times 10 to the 3 meters east. Then I'm going to box my final answer. Now, in this one, I put the answer in parentheses in kilometers, because I think that's what they had at the book. which is 2 kilometers east. The numbers in parentheses are the numbers that they have in the book. Okay? So that's A1. So again, we're going to write our given. We're going to write what we want to find. We're going to write our basic equation. We're going to rearrange the equation to solve for the unknown in terms of the known. We're going to substitute and solve, and we're going to carry our units through to check our work. And then we'll be successful in anything that we do in physics if we follow those steps. Okay, let's now try one for B. So now we're going to do B2. Or I don't know why I said 2. Let's do B1. All right, so we're going to write our given. And then we're going to write what we want to find. Now, what I would do is, if you want to do like all the A's on the front and the B's, you can do your homework out of order. So if you want to do B1 after A1 and then continue with A, that's fine. If you want to start on a separate sheet of paper, that's fine. If you want to just go to the back, that's fine too. Okay? So let me move this up. So remember, when we read the problem, we're going to chunk it. As we get information, we're going to write it down. So it says, as the shuttle bus comes to a sudden stop. So they actually tell me the word stop. Does that mean something? It does. When something comes to a stop, if it's already moving and then it stops, that means the final velocity is 0. To avoid hitting a dog, it accelerates uniformly at, so now my acceleration is negative 4.1 meters per second squared. As it slows from, so when I'm reading these problems, from is a key word. Because from tells me that's what it's starting. So my initial velocity is equal to 9. And then it says 20. So they actually all told me, which I already concluded from the stop, that the final velocity is 0. Find the time interval of the acceleration. So I want to find t. Now, if I look at the chart from the notes, again, how do I know which to use which equation? Now, these are the practice problems from the book. Now, this particular equation can be viewed two ways. One way is it says A is equal to delta V over delta T. But delta V over delta T, delta is the final minus the initial. And then if this is a time interval, it's T. But another way it appears is it says VF is equal to VI plus AT, but guess what? Can you see that means exactly the same thing? So I'll just start off with this because this says average acceleration. So here's my basic equation I want to solve for t. So I'm going to rearrange the equation to solve for the unknown in terms of the known. Well, I want t to be in the numerator all by itself. So I'm going to leave this alone, and so you don't get confused, I'll rewrite it. Here's my equation. So what I'm going to do is first I'll multiply both sides by t. I want t in the numerator by itself, so then I'm going to divide both sides by a. So I get t is equal to VF minus VI over a. So now what I'm going to do is I'm going to substitute in my values. So I have 12 meters per second minus 7, what am I doing, 12? Sorry. So I have VF, which is 0. So I'll just do it underneath. So t is equal to 0 meter per second minus 9 meters per second over negative 4.1 meters per second squared. So now when I do this on my calculator, do you notice there's a negative here and a negative here? So I'm going to have 0 minus 9 divided by, and remember it's a negative 4.1. So my answer comes out to be 2.19, but it's positive, but I'm going to put 2.2. Now I know time is supposed to be seconds, right? But I want to make sure I didn't make a mistake. I want to make sure my algebra is right. So I'm going to carry my units through and cancel them. So until we get in the habit of doing it, what do we have? I have a meter per second in the numerator divided by a meter per second squared. So let's look at it in fractions. That's a meter per second divided by a meter per second squared. And remember, when we learned in, 5th grade to divide fractions, it's like multiplying times the reciprocal. So that would be a meter per second times a second squared over a meter. So now this cancels with that, this cancels with one of these, and I end up with a second. Is that my correct unit for time? So I see I did not make an algebra mistake. So that's what's so great about physics. When you carry your units through, number one, it's going to make sure and tell you whether or not you forgot to do a conversion. Number two, by carrying your units through, it's going to check and see if you made an algebra mistake, because you'll see, do I get the correct unit I'm supposed to get for that? And if I don't, that means I made a mistake. So there's a foolproof way to check your work in physics. Now some people say, oh, I don't want to do that, that's so much work. Well, then you're the fool, because you don't want to have a way to always check every single problem you're going to do in this class, right? And that's it.